My dear students, today I am going to teach you missing plot technique in randomized block design, that is in RBD. Let the observation Yij is equal to x say in the jth block and receiving the ith treatment be missing. We construct the table, and in this way these are treatments and these are blocks, and we write y11 y2 up to y1t. In this way we write yj1 yj2, and this is the missing item, and yit, and up to yr1 yr2 yri yrt, and these are the total. These are the row total and column totals, where yi dot implies the total known observation getting ith treatment. Y dot z dash implies total of known observation in jth block, and y double dot dash implies total of all the known observations. And we know that total sum of square, total SS, is equal to double summation yij square minus CF, that is correction factor. And now our double summation yij square is equal to the missing item square, that is x square, plus constant with respect to x minus correction factor. And the treatment sum of square, we write it SST, is equal to 1 by r yi dot dash plus x whole square plus constant with respect to x minus CF. And SSB is equal to, that is block sum of square, is equal to 1 by t y dot z dash plus x whole square plus constant with respect to x minus correction factor, where CF is equal to, we know that CF is equal to grand squared total divided by n, and here G is equal to y double dot dash plus x whole square divided by RT. RT is equal to total observations. Therefore, E, that is error, is equal to residual sum of square is equal to total sum of square minus SSB minus SST, and we put the values. Total sum of square is equal to x square minus 1 by t y dot z dash plus x whole square minus 1 by r yi dot x dot plus x whole square plus y double dot dash plus x whole square divided by RT plus constant terms independent of x. Now we choose x such that E is minimum. We know that for E to be minimum, we must have del E by del x is equal to 0. That implies we differentiate the E and we get these values: twice x minus 2 by t y dot z dash plus x minus 2 by r yi dot dash plus x plus 2 by rt yi double dot x double dot dash plus x is equal to 0. And after simplification, we get the missing observation x is equal to this r y dot z dash plus t y I dot dash minus y bar y dash double dot divided by r minus 1 into t minus 1, and this is our one missing observation. This is our one missing observation. For two missing values, say x and y, say x and y, let R1 and R2 be the totals of known observations in the rows and containing x and y respectively, and C1 and C2 be the totals of known observations in the columns containing x and y respectively, and let S be the total of all the known observations. Now we construct the table in this way, and this is the missing observation x and this is y, and row total R1, R2 and column total C1, C2. Here the error sum of square becomes E is equal to x square plus y square minus 1 by t R1 plus x whole square plus R2 plus y whole square minus 1 by r C1 plus x whole square plus C2 plus y whole square plus 1 by rt s plus x plus y whole square plus terms of independent of x and y. Now we set x and y such that E is minimum. For E to be minimum, we must set del E by del x is equal to 0, and that implies x minus 1 by t r1 1 by r c1 plus x plus 1 by plus y is equal to 0, and del E by del y is equal to 0 is equal to 1 minus pi minus 1 by t r2 plus y minus 1 by r c2 plus y plus 1 by rt s plus x plus y. After simplification, we get in this way: r minus 1 into t minus 1 x is equal to r into r1 plus t into c1 y, and r minus 1 into t minus 1 y is equal to r into r2 plus t into c2 minus x s minus x. And solving these equations simultaneously, we get the estimates of x and y. Now the ANOVA is performed in the usual way after substituting the estimated values of the missing observations. For each missing observation, 1 degrees of freedom is subtracted from total, and consequently from error degrees of freedom. And this is the missing plot technique in RBD for 1 observation or 2 observations. Thank you.